Assalamualaikum and greetings. Today our group will be presenting our solid mechanic project titled Force and Factor of Safety Analysis from an Actual Structure. Okay, from here, our group consists of 4 members. That is me, Haris, along with my team members, Shahir, Hanafi and Afifi. Our project is systematically divided into 5 main sections. That is the introduction, literature review, methodology, analysis, and finally conclusion. For the introduction, the core objective of this project is to apply fundamental solid mechanics principle to evaluate the force acting on the Tun-Teja overpass bridge and calculate its factor of safety. We specifically choose this overpass bridge because it provides very clear defined load paths, making it highly suitable for an accurate detailed force analysis. It's utilizing this real-life structure allows us to practically apply engineering tools like free body diagram, that is FBD, and static equilibrium equation. This helps us deeply understand how modern bridges successfully maintain stability under various operational loads and how early design choices directly impact long-term public safety.
Now we go to structure selection. First, we have overpass bridge. Second, we have parking lot rooftop frame. And third, we have advertising tower. In this project, we chose the overpass bridge. For the materials used, first we use the reinforced concrete. It is because good for medium span. Second, we use structural steel. It is high tensile strength and prefabrication friendly. And lastly, we use pre-stressed concrete because it is ideal for long spans and reduce the deflection. For the safety requirements, we must use the wind resistant, structural integrity and electrical safety. Next, we use coatings, groundings and reinforcement. And lastly, we use the maintenance in a critical for long-term safety. Now we go to idealized model for each system. First is vertical load. The bridge must carry its own weight and live load, like vehicle and pedestrian, cause bending and compression. Second is lateral load. Horizontal force from wind, earthquake and temperature change can cause sway or crack if not controlled by joints and bracings. And lastly is support reaction. The abutments and piers provide supports, transferring load to the ground and keep the bridge stable.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanafi bin Muhammad Isan. My number matric is B1324-20013. So now, I will proceed this presentation with methodology. So for our methodology, we use a free body diagram or FBD to identify and analyze the force that acting on the bridge. So the values that we use in our analysis are a vertical load of 1250 Newton, a shear force of 1250 Newton, and a bending moment of 600 to 25 Newton meters. So using these values, we analyze how the structure respond to the different type of loading, including axial force, shear force, and bending force. So for the next is the load and stress analysis. So the result show that the axial stress is 70.5 kilopascal, while the bending stress is 7.15 megapascal. So this gives a total of stress of approximately 7.22 megapascals, which is, when we compare to the material yield strength of 250 megapascal, the stress is too much lower. So we have calculate the factor of safety, that is 34. So it means that the bridge is operating well within safe and limit, also can safely support the apply load. So for now, I will proceed with my last slide for this presentation. So on this slide, we discuss the mechanical behavior of the bridge structure. So first, the load is distributed symmetrically, which is it can help to maintain the balance and reduce the stress concentration on one side. So for the second, the truss system provide the efficient force transfer throughout the structure, allowing the load to be carried safely to the support. So the tension member are important because they resist pulling force. However, they are more vulnerable to fatigue after long-term repeated loading. On the other hand, the compression members resist pushing force, but they have a risk of buckling if the load become too high. Overall, the truss design help improve the strength, stability, and efficiency of the bridge. So that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afifi bin Rosnizan. Now I want to continue is suggestion for improvement. In recommendation, strengthen compression members against buckling using larger cross section, bracing or different profile can improve stability. Implement regular. Maintain strategy, long-term durability, rust prevention, such as paint and periodic bulk or well replacement help prevent degradation and extend service life. Consider wind and seismic load effect. While the analysis focus on vertical load, lateral force from wind or earthquake can impact the structure. Conclusion: the Tunteja overpass bridge is structurally safe under the applied static load, with all truss members operating well below their material limits. A high safety factor of over 34 indicates the bridge is over-designed for strength and reliability. To ensure long-term performance, regular maintenance and consideration of factors like corrosion and fatigue are essential. The analysis highlights the practical value of applying solid mechanics to real-world structure. Now, I want to say thank you from representative from our groups. Thank you and Assalamualaikum warahmatullahi wabarakatuh.